Section 4.3 is about rate of change. The rate of change is a rate that describes how one quantity changes in relation to another. So as it changes, typically we look at it as it changes over time. We're going to find its average rate of change over time. So this first example says, find a positive rate of change. That just means that it's going in the positive direction. It's getting bigger. It says the table below shows Julia's height in inches between the ages of 5 and 12. Find the rate of change in her height between ages 5 and 10. Okay, so we want to find her average rate of change from when she was 5 to 10 years old. All right, so we want to know how much she grew per year. In math, we say this per here is typically division. All right, so we want to know how many inches she grew between 5 and 10, ages 5 and 10. Well, to find that out, we say, okay, well, she's 60 inches now. She was 48 inches, so we subtract those two. And we're going from the age 10 to 5. This is giving me the number of years. And this is going to give me her height in inches. Okay, so if we subtract those two, we get 12. We get 12 inches divided by 5 years. So if we actually divide that out, if we go 12 divided by 5, she grew an average of 2.4 inches per year. All right, so that's her average rate of change. And that completely answers the question they were looking for. That's their rate of change between 5 and 10. Okay, example 2 says weight loss. The graph shows Celia's weight over a period of 6 months. Find the rate of change between the first month and the 6th month and describe how this rate is shown on the graph. All right, so here's the graph. Here it would be 0. And we're looking at between the first month. So the first month would be right here. So this, as it's going from here to the 6th month here. Okay. So these are the 2 points we're looking at. We want to know how much weight she lost per year. And typically our time is going to be on the bottom. All right. So her starting rate at month 0, so from 0 to 6, all right, her starting weight is 180. To find her change in weight, we're going to go 180 minus 120. So this is our, if you read our graph, the second number here, the weight, is 180. And in this case, that's after 6 months, it's 120. And then we're going to subtract. Okay, since we started with week 0, we're going to start with week 0 and we determine how many months it is. So it's 0 months minus 6 months. And why is that important? I'll show you here in a little bit. So we chose to start with 180 pounds and subtract 120 pounds to see how many pounds she's lost in that 6 months. So since we started with 180, we're going to have to subtract its x value or its month value first. All right, because, and I'll show you, 100 minus 120 is 60 pounds. All right, and 0 minus 6 is a negative 6. The reason why it's important is because we want a negative value down here. All right, we want a negative value because if you look at her weight is decreasing, and that negative sign shows that it's going down. The negative sign shows direction. It's showing that it's decreasing. So if we go ahead and divide that out, we get 10 pounds or negative 10 pounds, per month. So all that doesn't mean she's losing negative 10 pounds. It means this negative sign means that she's losing. If it was plus, that means she'd be gaining weight. So it is important, if we start with this certain one and subtract here, we got to follow that same suit when we subtract the bottom, the 0 and the 6 as well. Okay, so the reason that made a difference is because it made a negative. It showed us that she was losing weight and she was not gaining weight. All right. Example 3, it says we're comparing rates of change. The graph shows the temperature during the day over a 6-hour period. Compare the rate of change between 9 a.m. and 10 a.m. to the rate of change between 12 p.m. and 1 p.m. During which period was the rate of change greater? All right, so first of all, we're going to need to find our coordinates. It says from 9 a.m. to 10 a.m., Well, at 9 a.m., it's 15 degrees. So at 9 a.m., it's 15 degrees. All right. And at 10 a.m., it is 20 degrees. All right. So let's find that's rate of change from 9 to 10. All right. So again, let's go ahead. We're going to go, let's see, 15 minus 20 to see what the degree change. And it doesn't matter. We can go 20 minus 15. But remember, we got to keep the order the same in which we do it. So I chose to go 15 minus 20. And in this case, since I started with the 15, I have to go 9 minus 10. So this guy's rate of change would be -5 all over -1, or a negative divided by negative is a positive 5 degrees per hour. Okay? So let's check from 12 and 1. From 12 o'clock, at 12 o'clock, this table says it was 30 degrees. So it was at 12 o'clock, it's 30 degrees. And I'm going to put it in a nice little order pair here. And then at 1 o'clock, it was 35 degrees. So at 1 o'clock, it was 35 degrees. So now, when we're dealing with time, it can be a little tricky. If we were to, and I'll show you here in a little bit. So let's just choose which one we want to subtract. We want to subtract 30 and 30 minus 35. All right, divided by, if we stuck with this, we would go 12 minus 1. Now, time's a little bit tricky because it starts over after 12 and goes back to 1. That's why in military time, they'll use 13 or 14. They'll continue going that way. She didn't have an hour span, or the temperature didn't have an hour span of 11 hours. That's not right. All right, it had a span of 1 hour. So actually, if we wrote this in military time, it'd make a little bit more sense. So here we would have 30 minus 35, which is a -5, and 12 minus 13, which is a -1. And the reason I changed that to a 13 is because of military time makes it a lot easier to deal with, knowing that this is just a difference of 1 hour. It's not 11 hours. Okay, and so this has a positive 5 degrees per hour. And if we're comparing that rate, it seems like it's the same, right? So they asked us to compare the rate of change is the same as it was from at 9 a.m. to 10 a.m. and from 12 a.m. to 1 p.m. All right, maybe if this one was maybe 5.5, this would mean that it would be getting hotter per hour, is going faster. The rate of change is faster. If it was bigger, if it was smaller, it would mean it'd be going slower. But anyway, that's all I have for you as far as rate of change. I hope this helps. If it doesn't, you can rewatch it and ask questions in class. We'll see you in class.